Hey everybody, how you doing? Glad to have you here. My name is Keith Barker, and we just had a quiz on Sunday at 11 a.m. Pacific time. And what I did is I took that recording and then I edited it down. So if you're watching the recording of this, it's a lot quicker. Here's a quick breakdown of how it'll run. I'll introduce a question, and then I'll give you in the corner of the screen a countdown of
5, 4, 3, 2, 1, and boom!
And then the actual answer will appear, and then any explanations I include. Here is question number 1. What is used to access privileged mode after the admin telnets in? And 32 of us think it's green. Why is that? Let's take a look together. Let me go ahead and show media. What is used to access privileged mode after the admin telnets in? So AAA new model simply says that we want to use some more advanced authentication methods as opposed to just like local passwords on a system. So that enables the feature. And then AAA authentication login default group TACACS local. What the heck does that mean? All these words. Well, let's just spell it out. AAA authentication login. That means if we're talking to this local router or switch, it says, "Dear Mr. Router or Switch, when people want to do authentications, login authentications, like logging into the device, we want the default method to be a group of TACACS plus servers. Hopefully you have at least one configured and is reachable. That way, if Bob is authenticating this device, if that method is being used, this device can go check with the AAA server using TACACS and say, hey, this is Bob, and here's his password. It's all encrypted, but here's his password, and is it correct? And then the AAA server can respond back and say, yes. Now, this is the first method in the list called default. And the second method is local, meaning the local database. So let's imagine that the router or the switch, whatever this device is, can't reach a TACACS server, or we forgot to define one. Either way, if the TACACS server is not reachable, we can't contact it, we then go to our second method in the list. So what that means is, by default, the TACACS server group is going to be attempted for logins to this device, and if there's no TACACS server reachable, it's going to use the local database. Then this line says AAA authentication login VTY local. Now, what VTY is here, that's just a name of a method list. And that method list says it's called VTY, and if we call on that method list, we are going to use the local option, which refers to the local database on this device. Think of the local database like the running config on the local router or switch, because that's all it is. So up here we have a default, which applies everywhere, unless we have a more specific method list that's applied somewhere. So if the default's used, we're using TACACS, a group of TACACS servers in local, and then if the VTY is used, we're using the local database, the running config. And then we have a local username for admin, great, at privilege level 15, great, and the password, the encrypted password, the MD5 password that admin is going to use is Cisco 123. All right, and then we have the enable secret, super secret, which means if we're at user mode for any reason and we need to go to privileged mode, like level 15, we type in enable, press enter, and we'd have to type in that password. Then on line console 0, it specifies that the privilege level is 15. Bad idea for production, but if somebody walked up to this device and said, okay, here's what they do. I don't have a cable in my hand, but if they grabbed a cable, let me grab one. So if they grabbed this cable and they plugged it into a console port, on that console port, and then they connected their computer to it with a terminal emulator like PuTTY or something similar, basically privilege level 15 says, hey, let them in at level 15, at privilege level 15. So when we press enter, we're going to have privilege level 15 access. We don't have to type in enable at all. We'll just be at level 15 just by connecting right to the console port. And then we get down to our lines. So line VTY 0 through 4, which means anybody who's connecting to these logical VTY lines. So when somebody SSHs or they telnet to a Cisco device, they're logically connecting on a VTY line. 0, 1, 2, 3, or 4, or more. If it's a switch, they've got like 15, 16 by default, 0 through 15. But for these VTY lines, there's a line password that's configured, and then there's a method list that's specified for login. It says login authentication VTY, which points to this method list. And this method list says use the local database. So the big picture here is that if admin connects to this box and via telnet, because that's what the requirement is, he telnets in, he's going to be asked for his username because login authentication v2i says use the local database. And then it's going to ask for his password, which is Cisco bang23 with a capital C. However, that's not what this question is. This question says, what is used to access privilege mode after admin logs in? So when admin logs in on the VTY lines, one of the VTY lines, he's going to be in user mode. That's privilege level 1. And that's because even though his user account has privilege level 15 access, there's nothing on the VTY lines that says, let's do authorization or allowing an exec prompt based on his privilege levels. So he's going to end up at privilege level 1. And so if he wants to type in, he or she, the admin, wants to type in enable and press enter, which takes him to privilege level 15, the password to get to privilege level 15 is super secret right there. Is that more than what a CCNA should be aware of? The answer is no. You need to be aware of how that works. That is right out of the blueprint from Cisco regarding security. And here's the next question. Which host IP addresses could be used with a mask of 255.255.224.0? These are all valid. Every single one of these addresses could be valid. Join me for the playlist called Subnet Saturdays. If you're going to make a note, if you need to study IP addressing and subnetting, Subnet Saturdays is an 11 video playlist here on my YouTube channel, Keith Barker, that will give you the opportunity to answer all these types of questions correctly. So here's how I would tackle this. And again, as a review for those people who've been through Subnet Saturdays, I'd say, well, in this octet, which is the third octet, and there's 128, these are the values of each bit position. 128, 64, 32, 16, 8, 4, 2, and 1. All right, there we go. I'm just going to make a little note for myself. That is the second octet going that way. Third octet right here, just to make sure I remember where I'm at. And the mask says that bit is on, that bit is on, that bit is on, that bit is off here for the mask value, and that means the block size is 32. What that means is that the subnets for that third octet, octet A, octet B, and this is octet C, it'd be 0, and then we simply add the block size, 32, and 32 more is 64, and 32 more is 96, and 32 more is 128. You can do that longhand, shorthand, doesn't matter. But with that, then we have the last octet, D. And so with that knowledge, we say, well, the ranges for, we'll call this the first, this subnet and this subnet and this subnet would be for the last two octets, this would be 0.1 through 31.254, because that butts up against this next 32. And then for this one, it'd be 32.1 through 63.254. And all this I talk about in the Subnet Saturdays playlist. So if you're brand new to subnetting, just remember that you can go back to this quiz and give it another shot when you're ready. But for now, for people who understand a little bit about subnetting, this is an easy way to calculate it. And this is 64, first IP address on that subnet through 95.254. I'm just going to the next subnet and -1, and then -1 for the broadcast as well. 96.1 through, and it continues 127.254. So if we take a look at these addresses, and we're asking what could be valid host addresses, you basically say, well, how about this one? And we're really looking at the last two octets here. 129.255, 120, oh, that's up in this range. So if we continued it up here, that's in the 128 network. So that's a valid one. And then 100, that's in the 96 network. That's valid. Even though the last octet is 0, in the in this octet here, there's still bits that are on. It kind of looks weird, right? It looks weird because it's got that, but that's the range, 96.1 through 127.254, and those two octets fall in. So that's a valid host address. And so the ones that would not be valid host address would be like 31.255 or 63.255, because that would be the broadcast address for the respective subnet. Also, we couldn't use like 64.0 because that would be identifying this subnet itself. If we're taking an exam, like a real exam, we wouldn't need to go through all the ranges to calculate this. I did this as a question to help confirm that we could do it. But basically, once you know the block size and you know the ranges, you can just kind of eyeball it and say, yeah, that fits or that doesn't fit. And it's okay. I want to tell you this too. It's totally okay in an exam environment to take a few minutes, 3-4 minutes on a question that involves some calculations. No problem. Because a lot of the questions are a configuration like which route or would you need to add and stuff like that. So think about those and take time. Don't rush those. But at the same time, a lot of the questions, there's like 100 plus questions, like 102, 103 questions in your CCNA exam. A lot of them are just going to be, do you know how this works? And if you do, answer this question. So it's like 30 seconds, 45 seconds, click, 35, click. And then for the ones that go longer, don't sweat it. Now in a CCNA exam, you cannot go back. It's a one-way ticket. So you answer a question, you say goodbye to it, you have a little party, yay! And then you simply move on. So it's a lot of fun. The CCNA is an important stepping stone in most people's careers in learning networking. It'll get you a little bit recognition, like, okay, we're sorting out resumes and who's got a CCNA. Okay, the people who do might float to the top a little more than the people who don't. And then there's the CCNP, the professional level, and those are going to float to the top a little more than people that don't. And then behind that, this is important, do the hands-on practice. And as soon as you get your entry-level job in the world of IT, keep on studying, keep on studying, keep on studying, and just don't stop. That's the secret. I've been doing IT for like 30 plus years. I'm the OG of IT. And my secret is that sometimes I have to relearn things. Sometimes I have to learn new things. And the game is just keep learning. Just keep studying and applying and practicing. And that's really the only secret. Just don't give up. Just don't stop. All right, getting off my soapbox now, going back to the question, clearing off the screen, and one last push for Subnet Saturdays, that playlist, which is on YouTube, on my YouTube channel. It will help you master all these kinds of questions. Here's question 3 of 8. It's double points. Using Telnet, okay, I have to tell you, these are all randomized. So I didn't plan on these being back-to-back, but they are. It's the same exact config, but the question is different. Good luck, everyone. All right, the password of Cisco 123. I've got quite a people on that answer. Let's see, why is that? Show media. So using Telnet, which password is used during the authentication? So basically, if we look at the Telnet and SSH, when we connect to it, we're connecting on the VTY lines. So if someone connected to this device on the VTY line, there's a password here, but AAA new model is already invoked, and that basically changed the rules. And then here's a login method list, a login authentication method list called VTY that says use the local database, which is right here. They're running config. And so basically, yeah, if somebody connects to this device, it's going to ask them for their username, which is going to be admin in this case. And then it's going to ask admin for his password, which is Cisco bang23 with a capital C in front. And that literally is the answer to this question. And that's why. Okay. Also, I want to, I realized a couple days ago that I have a lot of cool, fun things that I get to play with. And like in the background, I've got, racks of servers, and I've got a lot of live gear as well. And I thought, whenever possible, as far as demonstrating something, I'm going to try to use more Packet Tracer, because I talk about how amazing Packet Tracer is for studying CCNA. It's free and it's fast. And that's true for a scenario like this as well. So here's my challenge for you, is that you could take this configuration as it is, and you just go back to the video, pause it, and you could actually just bring up Packet Tracer on your own, config T, go into configuration mode, put these commands in, and then for testing Telnet, you'd also want to give yourself, the router or switch, an IP address. So if it's a router, you could create a loopback interface, or a switch, a loopback interface, give it an IP address, and then from the CLI, just connect to yourself. It's like you're talking to yourself. Yes, just Telnet to yourself, and you can verify exactly what's required, what's going to happen, how it looks. And that's a really good way to learn too, especially when it doesn't work like you thought it would. Like that happens to me all the time. It's like, oh, I expect this to happen. It's like, didn't happen. Why? And a lot of times it's troubleshooting. some error, or it's just like it didn't work as I thought it would. So practice, lab it up, and that'll help you a bunch for not just learning how AAA works and authentication works, but it'll also help in production when you're trying to connect to a remote system with SSH, not Telnet. But you're connecting with SSH and you're verifying whatever it is you're verifying or working with, or you can't connect. Having the skills of how it works is a big step in getting it to function. All right, so thanks for joining me for that question. Let's take a look at the next one, which is this. Question 4 of 8. It's double points. Yay! You need to support 29 hosts. What network should you use? And here's 4 choices. Good luck, everybody. All right. Well, we've got 37 people on the right answer, which is a good direction to go because that is the correct answer. Now, so again, if you're new to IP addressing and subnetting, the playlist Subnet Saturdays is, I think, indispensable, as you won't need to learn about 2 to the power of anything. All you need to do, I talked to Randy yesterday, and you got to bring your thumb. If you have your thumbs, you can do the calculations. And so to figure this one out, here's how I would pursue it. And the cool thing is I got to do this with you right now because I haven't memorized this answer. I wrote it this morning, but to sort it out, how do we support 29 hosts? Well, we have 2 parts of an IP address. You get the network portion, and then you have the host portion. Think of it like, a street. You have a street name, and you have a house number on that street. And the dividing line is where the mask ends. So the mask is like in binary. That's the sound it makes. And then 000000000, and that's what the mask does. The mask says where the dividing line is. So if we need to support 29 hosts, the question is how many bits do we need to leave available for hosts? That's what this question is about. And so if we have 32 bits total, and how many of those bits in this IP address, how many bits need to be the host bits? And the answer is the thumb game. And the thumb game goes something like this. You put if you know the thumb game, first of all, if you know the finger game or the thumb game, give me a comment saying, yep, I know this game. And I'd like to just get a look at the feedback in a moment about how many people are using this or know this technique. So if we need to support 29 hosts, which is what the question said, how many host bits, that's at the far right-hand side of an IP address, how many host bits do we need for that? And so you put your thumb in the air, and on your thumb there's a 2. So verbally you're counting out how many hosts or subnets, depending on which one you're calculating, and how many hosts, and then the fingers represent, digits represent bits. So 2 is not enough, 4, not enough, 8, not enough, 16, not enough. We're going for 29, 32, minus 2, because you can't use the all zeros or all ones for host bits, because that's the network and broadcast respectively. So we need 5 host bits. 5. We need to leave 5. So if you have 32 bits in an IP address and you need to leave 5, that means the other certain quantity of bits would be used for the network and the mask. And so if you're not a real fast math studier, like I'm not, you could just say, okay, we need 5 host bits over here. 32 minus 5. There's a 2. That's a 5. That's a 7. And so it'd be a 27-bit mask. So the mask would be /27. And that would be written out as 255.255.255. That's 24. And then it'd be 567.0000. And then we just add those up if we had to, but that's 224 for that octet as the mask. That's the decimal representation of this octet of the mask. And what was the question? Okay, so a /27 is going to support 30 hosts per segment. And so we're looking for a /27, which is a 224 in that octet. So basically, that could be it possibly, or that could be it possibly. That's too long, and that's too long. All right, so we're narrowing it down to the mask. And now the question is, which network should we use? And if we have a 224, this is a 30, that bit right there, the last bit of the mask is 32. So our block sizes for that 4th octet, our networks are going to be 0, 32, 64, add 32 more, 96, 128, 160, and I'm just adding 32, 64, checking my work here. Great. So we're just adding adding the block size. All this is taught in Subnet Saturdays, one logical step at a time. And so the networks would be, here we go. So this is network 96 right there, and 112 is not one of our networks. That would be a host address on the 96 network. It's not actually the network address. So the question is, what network should we use? This was a combination of figuring out what the mask should be and then picking out a valid network as opposed to a host address on some network. All right, don't shoot the messenger, but Subnet Saturdays is going to be super helpful for you. And I really don't think, my friends, I don't think there's a way that you can avoid IP addressing and subnetting. I mean, networking. Switching is important. The infrastructure and spanning tree and forwarding frames and all that and trunking, it's all really important. But routing of packets and IP addressing, which is kind of tied to everything, is really important to know. So carve out a little time. Carve out a teeny bit of time, if you haven't already, to go through all 11, soon to be 12 videos in the Subnet Saturdays playlist. And I have people who come to me all the time. It happens on at least a weekly basis, sometimes not daily, but multiple times a week, where people will reach out on Discord or through email or comment and saying, "Oh my gosh, you know what? I didn't think I could do subnetting. It looked really tricky." And then they totally say, "I totally get it." And then when I have a chance to talk with them personally, or like on Discord or chat in a group, I'll say, "Hey, can I ask you a couple questions?" And I'll ask a couple questions about, a subnet, or how many hosts, or what would the new mask be if you need 15 new subnets or whatever it is. And I don't see them, but I imagine them going, and then they tell me, no paper, no nothing. It's like, yeah, okay, you did it. So my encouragement to you is, let's get on board. If you are not yet competent, really able to do the IPv4 calculations for subnetting, soon to be supernetting with summarization. I'm going to make another video on that. Give Subnet Saturdays a whirl, take them in order, do the exercise that I assign, and you'll leave that with a skill that you can use the rest of your life, or as long as you work in IT. If you have a loved one who's not in IT, they may not appreciate it. But as far as working with IP addresses and subnetting, boy, that'll help you the rest of your life. Next question. This is question 5 of 8. Which can use a checksum for data integrity? Wait. Stop the truck, Keith. Are you trying to tell me that all of these have checksums? And the answer is yes, I am. So if we did a protocol analyzer, or you looked at the RFCs, or you just Googled checksum with any of these protocols, IP refers to layer 3 packets. And those layer 3 packets have a checksum field. It's for data integrity. How do you verify? We're on a packet. Layer 3 is not connection oriented, but there is a checksum field that can be used to validate the integrity of that packet at layer 3 in the layer 3 header. ICMP is a maintenance protocol that's used with IP. It's used for a lot of cool things. Like when I do a ping, it's using ICMP. Protocol number 1, I win. That's the protocol number for ICMP. But anyway, in the ICMP header, guess what? There's also a checksum. TCP, that one, you just I know that's going to happen by default. TCP headers have a checksum value that can be used for verifying the integrity, that the data hasn't been messed up, that it's okay. And UDP does also. It's like, what? Stop the truck. Everything in my life has told me that UDP is unreliable, connectionless. That's all true. It is. That means it's not doing a 3-way handshake, UDP. I don't do a 3-way handshake. I don't verify that the sender and receiver can talk and everything like that. However, the individual segments at layer 4, the individual UDP segments absolutely have a checksum field. And that can be used by an upper layer application like TFTP or something to verify that each of the packets, each of the segments at layer 4 that come in, the UDP segments, are intact, meaning that they haven't been corrupted to the right size, the hashing algorithm works against it, or the checksum, so that we can validate at least that one little chunk of data wasn't mangled on the way. All right, so now you know TCP is connection oriented. 3-way handshakes to set it all up, sequencing, acknowledgement, sliding windows, all that great stuff. UDP, connection less. Couldn't care less about the overall session. Do we know? Are we expected? We don't know. UDP is sending UDP segments. But whether it's TCP or UDP, all of these at layer 3 and layer 4, respectively, they all have a field for a checksum, which can be used for data integrity. All right, don't shoot the messenger. It is a tricky question too, but I wanted to make sure that if you're studying for CCNA, that you have this ammunition in your awareness as regard to how the protocols operate. All right, here we go. I need to get my face off the screen. Bright Chicken, first place, 12,000 points, and change way up there, followed by a few others who are hot on the tail. 12 players just hit answer streak number 4. Oh, it's on. It's on. Question 6 of 8. Here it is. Multiple select IPv6 OSPF is enabled on gig 00. Which multicast groups has this router joined on that interface gig 00? Okay, IPv6 OSPF is enabled on gig 00. I don't need to draw that. Just imagine a router has an interface that it's enabled. So it means a couple things. If OSPF is enabled on that interface, it means that IPv6 unicast routing is enabled. So let's circle those as they come up. So when we put an IPv6 address on an interface, that interface is going to join the, hey, I belong to IPv6 multicast group. That's this one, FF02::1. If a router has IPv6 unicast routing enabled, meaning it's willing to route IPv6 packets for other people, like IPv4 does by default on most Cisco devices, if we enable that, it's going to join this group, which is all routers who are running IPv6, FF02::2. And if we enable OSPF on that interface, it would have joined this group at least, which is FF02::5, which is the multicast group that it would join. And if it was a DR, doctor, give me the news, or a backup doctor, which stands for designated router, not really a doctor, it would also have joined FF02::6, which is what those designated routers are also going to join. And this over here, A is hexadecimal for decimal 10, and that would be something else, maybe EIGRP. I was talking to Kelvin this morning. I said, Kelvin, what is A again? I think he said EIGRP. And then I think RIP uses 9. In any event, these are the 3 answers that we were looking for. Multicast and IPv6, those basic concepts, these concepts here are well worth knowing. That's why I bring them up. And let's continue on. Oh, and if I haven't said it already, I am super glad that you are here. Thank you for joining me for a few minutes. I look forward to these times we have together. If you want to come and join me on Saturdays, 10 a.m., I have a instructor office hours that's free on Discord. Come and join me. For question 7, here it is. Which of the following are in a quote-unquote private address space? Good luck, everybody. All right. I like that. So let's take a look at the answers here. 192.168. I put the 168 there, but for the Class B, the RFC 19, let's put that up here too. RFC 1918 is a document that talks about IP addresses that can be used for private enterprises, meaning you don't have to be connected to the internet to use them. They're free. You can just use them willy-nilly inside your networks, and Company A can use some, and Company B can use the same exact range, no problem, because they're all in their own private enterprises. So for the 10 for the Class A space is 10 anything. For the Class B space, and anybody can use any 3 of these they want, any ranges. The Class B range is 172.16 through 31, anything. And for Class C, it's 192.168. anything. Those are it, right there. So this guy, 172.168, doesn't fall in that range for that second octet. That's why that's not good. 172.31 does, and that's why that's a winner. And then 192.186, dang it. Who would do that? Who would flip 192.168 to 192.186 just to make people think about looking at details for addressing? Keith would. Yeah, that's what that is. I just flipped it. That was intentional, just to help drive home what those ranges are. And then this guy right here, which is the unique local addresses for IPv6, which is FC00::7. I think I'd like to take a moment and talk about what that means too, by the way. So in IPv6, each of these characters represents a nibble of data, I say. So a nibble is just 4 bits. A byte is 8 bits, a nibble is 4 bits, and half a nibble is a chew. That last part's a joke. But 4 bits really is referred to as a nibble. They call it a NYBBLE, like a byte versus a nibble. Anyway, so with decimal, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. We have 10 digits, 0 through 9, and then once we get past 9, we carry the 1 and continue on. We use base 10 probably because we have 10 digits. I'm not a mathematician or expert on that, but that's a good guess at why. But anyway, that's decimal. So for hexadecimal, so this is decimal. So for hexadecimal, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but it's base 16. There's 16 characters. And so as it goes on, for decimal, it'd be 10, 11, 12, 13, 14. I'm running out of room. 15. Okay. And in hex, it'd be A, B, C, D, E, and F. And then in binary, those would be representing 4 bits. So those would be 0, 0, 0, 0. And then you start counting 0, 0, 0, 1, 2, 3, 4. This takes concerted effort for me to do, frankly. So basically, that's the numbers there in binary, just 4 bits with the 1, 2, 4, and 8 values there. So we get down here to 10. That would be an 8 plus a 2. That's 10. And make sure 8 plus 2 more is 10. 1, 2, 4. Yeah. That's 10. And then 11, B, and C would be 1, 1, 0, 0. And D would be 1, 1, 0, 1. And then E would be 1, 1, 1, 0, and F would be 1, 1, 1, F. 1, 1, 1, F. That's my brain flipping between hex and binary. So when we have a unique local address, and it's FC00/7, that means the first 7 bits have to be, we'll take F. So I'll put it up here again, FC00. So the F is going to be 1, 1, 1, 1, based on this right here. And then the C is going to be 1, 1, 0, 0. 1, 1, 0, 0. That's this nibble right there. And then when they say it's FC00/7, they put the zeros here because they want you to know which position it's in. So there's 16 bits here, and they want you to know that the first 4 and then the second group of 4 have to be in this position. The rest could be anything. We care about the first 7 bits. So that'd be I care about 4, 5, 6, 7. Have to be those right there. So that would also mean, what if we had this 1, 1, 1, 1, 1, 1, 0, 1? If we don't care about that last bit right there, this would be F, and this one would be 1, 1, 0, 1, which is D. So if we saw any addresses that start with FC or FD, those are both unique local addresses in the world of IP. They're routable. Sort of like an RFC 1918 address for IPv4. They're both routable. We may not see these used very often, but we know what they are. So if we see FC00/7 as the space for the unique local address space, the addresses could literally start with FC or FD because of this last bit, which isn't used as part of the requirement for those first 7 bits. All right, I feel better. It's like therapy. It's like math therapy. So the hexadecimal piece also, you will be helped when you work on your binary inside my Subnet Saturdays. And again, I'm really easy on you. We'll take it one step at a time. Subnet Saturdays, all I need is a commitment from you that you want to invest the time doing it, go through those videos, and then come visit me in office hours. If you want clarification, go through the practice quizzes so you can nail it. All right, private address spaces. A little bit of a tangent there. Oh, let me mention this too. Virtually nothing that I say in these quizzes is irrelevant for a CCNA. Wink. All right, so thanks for letting me elaborate on FC00 and FD and how they're both a unique local address for IPv6, and also talk about the RFC 1918 addresses. Let's go on to our next question. All right, here we go. Let me clear off the screen. I'm excited. All right, and here we go. Last question, and then we'll take some questions from the queue. Question 8 of 8. Which of the following are true about MAC media access control or layer 2 addresses on Ethernet networks? Good luck. Last question. No pressure. So they are 48 bits in length. That is true. We can reuse them in 2 different VLANs. What? Wait, no, that can't be true, Keith. Can't be true. Like, when I was studying CCNA, they told me that every single layer 2 address has to be unique. In the VLAN it's in. For example, think about the street that you live on right now, or if you're in an apartment or building or whatever that is. There's a house number or a building number on that building on that street. And let's imagine, just for grins, that our building number is 7417. That's our house number on that street. 7417. And what happens if we have 2 streets away? Like, we're on First Street and they're on Elm Street. Couldn't they use the house address of like 7417? That's for IP addressing. They can use the same host address portion on a different street or a different network. In that same light, we can use a different layer 2 address on a different VLAN, a different network, because nobody cares. It's unique for that VLAN. So if we had a router, let's call it router 1, and it was connected to 10.1.0.0 and 10.2.0.0 there with 24-bit masks, whatever it is. And then, and this is interface gig 0/0, and this is gig 0/1. Now, there's a burned in address called the BIA. If you do a show interface gig 00, it's going to say, here's the BIA and the MAC address, layer 2 address. But we could manually go in and specify a MAC address. So we could specify, for example, 000011111111 here. 1, 2, 3, 4, 5, 12 digits. 12 times 4, 12 is 48 bits, great. And we could have that assigned to this MAC address on this network, or to that interface. And we could also assign that same layer 2 address to gig 01. It's in a different VLAN. Doesn't matter. It's just when you have 2 MAC addresses that are exactly the same in the same VLAN, the same layer 2 broadcast domain, that's when it becomes a problem. All right, they are represented in hexadecimal most of the time, and they must be unique within the same VLAN. All right. Don't shoot the messenger. Just wanted to share that with you. And let's go and take a look at the podium. And a moment of silence, please, as we take a look at those people who crushed it. I also want to point out that if you participated today, you also crushed it because you're showing up. Showing up is half the battle. Show up, study, get better. Show up, study, get better, and just wash, rinse, and repeat forever. And that's how you win. Just keep on getting up, keep on studying, keep on practicing. All right, here's the podium. Up at the top left, I'm going to draw your attention to this bad boy right here. Let me bring my face back in for a moment. That's how many questions were answered correctly overall, and 23%. So a little teeny bit of room for improvement. And these are the most difficult questions. And unfortunately, it's all 8 of them based on the whole. So here's what I'm going to do. I'm going to, after this is done today, which will be done here in a few minutes, I'm going to stop the stream, and then I will save this. I'm recording locally. So what I'll do is I'll edit it down to a nice, concise, tighter package so you can look at it later with and take it, optimize our time. And then when you're ready, like after you've studied subnetting or you want to come back to take another look, take another hit at it. And if you wait like a week or two between looking at this quiz and looking again, you're going to forget what the answers are, and also, or you might forget what the answers are. And that's important. It's important not just to see a question and then say, oh, I know the answer's red, and just stick on that. It's more important to say, can I figure this out? And do I know how to solve this? Do I know why the answer is correct? That's what I'm going for. That's the success I want you to have, is to master the content as we go through. Also, I would love your feedback. So if you would take a moment if you're logged into the game, and there's a bunch of people who are, again, thanks. Go ahead and provide your feedback on, is this effective? And also, I have a new topic. Kelvin, I was chatting with him this morning. He recommended that next week we have a quiz based on something about network design. And that way I can include all the cool stuff about leaf and spine and 2-tier and 3-tier and those kind of things. I can also probably incorporate a few other aspects as well. So that's coming up next week, 11 o'clock a.m. Pacific time next Sunday. So that's it for this quiz, this recorded version and the edited version. Thanks for joining me. If you want to participate in the live quizzes, we have them every single Sunday Pacific time at 11 a.m. I'd love to have you there. Meanwhile, have a great day, and we'll catch you in the next live event.